So hello and welcome back in the second video from the tutorial focused on installation of Indexer on our Raspberry Pi node. In the first part we set up our external storage and installed all dependencies, and in this part we will configure our node accordingly. We will also move all of the dependencies to our external storage, and finally we will set up the database and the Algorand Indexer daemon on our Raspberry Pi. So in the first step, what we want to do, we want to move all of the dependencies which we mentioned before to our external storage, where the easier one is to move directly, for example, the node itself, which we for our previous storage on the Raspberry Pi SD card, to our external disk. So this can be done in this way. In case you want to keep the node in both directories, you can just basically change the MV to the copy, so that way you will have the node still in the previous directory, but you can also copy the corresponding directory to the external storage. Important to mention, recommended to turn off the node before moving it to the external storage. Of course, we can later on start it again without any issues. And the reason why we have to move it to the external storage, that after we change it to the archival mode, all of the blocks will be stored at the place or at the location of our node, and therefore it's important that this whole directory is on the external storage. Otherwise, of course, you would run out of space, because all of the blocks will be downloaded to the directory on our SD card on the Raspberry Pi. So unless you have enough capacity of the SD card, it's recommended to move everything to the external storage. Second part, which is a bit more challenging, is to also change the data directory of the Postgres database. In case you want to find out where is the Postgres configuration file, you can execute this command. For me, I already have the answer, so I can just directly navigate to the configuration file itself, which is stored in this path. And here the most important part is the part of the data directory, which is originally directing me to the varlib PostgreSQL 11 main, but I want to change it to the data directory on my external storage, so I modify this path. What is now important is that we do these changes also on our external storage, meaning that we actually provided the corresponding information and prepare the path as mentioned now also on our external storage. And this can be done by synchronizing the Postgres files to our external storage with the usage of the following command, where for me, as I have slightly different path, I would have here the data, and this is something actually what you have specified. So of course this path will always be up to date according to you, and this way the Postgres database stored on the original place on the SD card will be synchronized to the storage on our external storage. And in order not to also confuse the Postgres when looking for the files for that part, we also move this main file. So from the original path we also modify it to the main.back, like backup, and that way in case the Postgres is actually looking for these files, it will not be possible to find them. And it is important that the owner of the directory on the external storage is the same owner, in this case Postgres, in the group Postgres, is the same like the owner of the configuration file, which is stored in the etc Postgres 11 main, where the 11 is the version of our Postgres, where we see that this is also user Postgres from the group Postgres, and it's important that those two are matching. Otherwise, during we want to start the Postgres database, it will not work. So in case you are using the ext4, you can modify this user ownership very nicely using change owner attributes on the whole directory. And second important part is that the corresponding rights for the corresponding directory are 750 or 700, meaning that the user basically can do all read, write and execute, but the people from the group can only do reading and execution but cannot write, and all the others cannot do, or the rest of the world cannot do anything with this directory. So both of these options are valid, and this can be done by using the command change mode. And as I was mentioning, I was using the NTFS file system, and for that there is the little issue that actually it does not support such a granularity on the configuration of the individual files. So there is a workaround which is working, but I don't find it really optimal. So which is that you actually have to already during the mounting, you have to specify who can have which permissions to which files. And this is done basically by specifying the ID of Postgres. The group ID is also Postgres. The masks for the files is all zeros, which means that it's actually 777 for the files, and for the directories the mask is corresponding to, it's basically a reverse, it would be in this case 750. And then I specify, same as in normal cases, I specify the disk name and the directory to which I want to mount it. So at the end, important is that this, meaning that the file of the Postgres with the configuration and all of the corresponding configs, group and ID are matching to the one on the external storage. And finally, after this is done, hopefully you will be able to successfully format your Postgres database using this command, and also you can, just in case, restart the service. So basically all of the configuration will be successfully started and everything should be up and running, and that way our Postgres database is running. And next, after our database is running, we want to configure our node so it can be running in an archival mode and also in the indexer active mode. So this is done by navigating to our directory of the node. So depending on your path, where is your directory, you can navigate to the node directory, which is in my case is this path, this metadata archival mode. So I created a new, and here I have this config.json. In case you don't have this config.json there, you can copy it from the previous directory. So you can find the draft of this JSON in there, and here you have to change the field of archival to true, and then you can also search for the is indexer active exactly in here, and also change it to true. Looking for the configuration, in case you don't have it in your directory for the node yet, you can use this config.json.example, and you can just copy it as to your testing directory, and then you can navigate to it and modify it as mentioned before. And finally, you can start your node as expected, and that way basically your node will already run with the corresponding configuration, which might take some time. So depending on the speed of your internet and the hard disk you are using, you have to assume that it will take at least 10 days to fully synchronize all of the blocks to your local storage, and that way basically all of the Algorand blockchain will be running on your node locally. And the next part, the final step, what we want to do, so this actually can be done in parallel. So we want to actually now start with the part of preparation of the Postgres database, as mentioned before, for the indexer. And this is done in a few steps. So firstly, we have to specify or create a certain database. So here you can choose the database of your preference. Then you can also create a new user, or you can just alter the password of the default user, which is Postgres. So I just alter the user password Postgres to Postgres. So nothing big, it's just for the testing purposes. And then you also have to find out the port on which, or you can also modify it, of course, on which your database is running. So this can be done by navigating to the configuration file, where here you see the port on which your Postgres database is running. So the default value is this 432, which is the one I also set for the configuration. And finally, we want to start the daemon, which has the following syntax. So we specify the port, which in our case would be the 5432 or any other stuff. Then we will specify the database name, which in our case is db name. Then you specify the password and the username of our user, which was Postgres and Postgres. And in case you just want to run without SSL in the first phase, you can just run SSL mode disable. Then you specify the directory where your node is running, and you also specify the token of your corresponding node. And same as before, you can actually find out the token in the directory of your node, and it's always the same. So I also have here prepared test data node, where here I can see the Algorand token. So after upgrading this accordingly and running it, you should hopefully see that everything went through successfully. And now you will have to, of course, wait again for quite some time till the Postgres database is built with all of the entries from the Algorand blockchain, which might take some time, especially depending on the speed of your hard disk. And you can keep a track on you can keep an eye on the transactions, how it looks like. So I'm actually piping all of this output into a specific file, so I can show you how this looks. So I have it stored in documents or round.log, and here you see the round of the corresponding transaction modification, how long did it take to import this data into the database, and basically how many transactions were part of this block. So you see that there is something happening every couple of milliseconds, but of course going through all of the millions of blocks will take some time, so stay patient. And of course, second part, you see that each of the import of the different transaction takes different time, depending actually on the size of the transactions which are part of the individual block. And in case you want to a little bit debug and see how large is how fast is your database growing, you can also use this command, disk usage, on your Postgres database. And in case you already want to verify that actually your database is up and running, you can do it easily by using curl on the local host, where 8980 is the port of the default port of the indexer, and you can just run it to get back the health of your indexer, where here you see that it's actually running successfully, and you see in which round the indexer is currently running. So you don't have to keep an eye on the rounds, but you can basically just track it with using this health message and execute it once per time. So with that, we basically covered all of the parts. So we have the external storage setup, we installed all the dependencies, we modified the configuration file, we move all of the dependencies to our external storage, we set up the database, and also the Algorand Indexer daemon. So to summarize, today we have learned about Indexer and in which mode it can operate. We set up an external storage for our Raspberry Pi, which I would recommend should be 1 to 2 terabytes of storage. We installed the Algorand Indexer and other dependencies on it. We changed the node settings to become an archival and indexer node. And finally, we move all of the dependencies to the external storage, and we started our daemon, which is running in the database updater mode, where we basically are fetching all of the latest data to our Postgres database. So later on we can query for all of the available data in the database. And with that, I would like to thank you for your attention, and feel free to reach out in case you have any questions.